It begins like a heartbeat, deep beneath the ice. At first, no one notices. The wind howls across Alaska, the sea roars, and Shishaldin sleeps beneath its snow-white cone. But tonight, that silence breaks. Cameras capture something incredible. Lava fountains surge from the summit. Glowing rivers spill down a mountain once thought calm. The sky lights up, orange and red, like fire painting the darkness. Pilots see it. Satellites record it. Heat signatures flash on screens. Scientists whisper words they hoped never to say again. It's not a surface event. It's systemic. What's rising from Alaska's edge isn't just another eruption. It's a signal. The cone is waking, and the chain beneath the Pacific may be shifting with it. Let me tell you about Shishaldin, far out on the Aleutian chain, 1,000 miles from Anchorage. Stands one of the most beautiful volcanoes on Earth. A perfect cone, 10,000 feet high, elegant, ancient, alive. The island sits at the edge of the Pacific. Storms hit it constantly, snow covers it year-round. But beneath that white surface, fire burns. Shishaldin erupted 25 times since the 1700s. Most eruptions were small, quick bursts, brief shows of power, then quiet again. People got used to it. Just another volcano doing volcano things. But tonight is different. The summit glows brighter, stays lit longer, hours pass, the fire doesn't stop. This isn't normal. Lava fountains shoot into the sky. Gas plumes rise, lightning flashes inside the ash. It looks like something from another world. Fishermen notice first, they radio each other. "You seeing this?" A pilot reports it. Huge glow on the horizon. Changing course. Webcams capture time-lapse footage. The mountain pulses with light. To most people, it's a spectacle. Beautiful, dangerous, fascinating. But to scientists, it's something else. It's the start of a chain reaction. Think about what a volcano really is. Not just a mountain, not just rocks and lava. It's a window into Earth's depths, a place where the planet's inner heat breaks through. And Shishaldin sits on one of the most powerful zones on Earth, the Pacific Ring of Fire, where massive plates of rock slide beneath each other, where pressure builds for centuries, where energy waits to be released. Every eruption tells a story. This one doesn't fit the pattern. The data shows something scientists didn't expect. Thermal output 3 times higher than the last big eruption. Deformation measurements off the charts. Magma moving fast, too fast. One scientist stares at his screen. This doesn't match any previous cycle. Another checks the numbers again. The pressure is coming from deeper than we thought. Deep beneath Shishaldin, something's changing. The Pacific Plate slides under Alaska. Has been for millions of years. Heat builds, pressure builds, time passes until something breaks free. Usually it's small, manageable, expected. This time feels different. The volcano's perfect shape matters. That symmetrical cone isn't just beautiful, it's functional, like a gun barrel. Pressure builds vertically, straight up. No escape routes. When it releases hard. The mountain stands alone on its island, surrounded by ocean, battered by wind. But tonight, it dominates everything. The glow spreads for miles. The heat registers on satellites thousands of miles up in space. Ships change course, planes reroute, people watch from distant shores, and deep in monitoring stations, seismographs start showing something new. A tremor, steady, rhythmic, harmonic tremor, they call it. The kind that comes before something larger, the kind that says, this is just beginning. Every volcano tells a story, but this one doesn't fit the pattern. It's stronger, longer, deeper, and it's not stopping. Scientists watch their screens, check their data, run calculations. One thing becomes clear. Shishaldin isn't just erupting, it's awakening. And when a volcano this size wakes up on one of Earth's most active chains, the question isn't if something bigger will follow. The question is when. The cone glows against the night sky. Perfect, beautiful, deadly. Nature's most elegant formations hide the most explosive dangers. And tonight, we're watching that truth unfold. In fire, in ash, in light. The awakening has begun. Every volcano has a pattern. Scientists study these patterns, learn them, predict them. But Shishaldin's breaking the rules. In monitoring stations across Alaska, experts stare at their data. Something's wrong, or rather, something's different. A volcanologist checks his readings. This doesn't match any previous eruption. Another leans closer to her screen. The deformation data. Look at this. The numbers tell a story. Shishaldin erupted in 1999. Big eruption. Ash shot 50,000 feet high, one of the tallest ash columns ever recorded in Alaska. But even that eruption ended quickly, hours, not days. This time, the activity continues, sustained, stronger. The thermal output measures 3 times higher than 2019. 3 times. That's not a small increase. The ground itself is changing shape, swelling, rising. Magma pushes up from below. Fast. A scientist explains it simply. The mountain's inflating like a balloon, but this balloon's filled with liquid rock. Cut to the data. 3-dimensional images show the magma chamber. It's growing, filling, pressure building, with nowhere to go but up. Here's what makes Shishaldin special. That perfect cone shape. Most volcanoes have vents, cracks, weak points where pressure can escape. Shishaldin has one main conduit, straight up through the center. Like a chimney, all that pressure funnels through one path. When it erupts hard. The symmetry isn't just beautiful, it's functional and deadly. But there's something deeper happening, something beneath the volcano itself. Shishaldin sits on the Aleutian chain, a string of volcanoes stretching across the North Pacific. Beneath this chain, 2 massive plates meet. The Pacific Plate slides under the North American Plate. This process takes millions of years, creates incredible heat, unimaginable pressure, and volcanoes, lots of them. The Aleutian chain has over 40 active volcanoes. They're connected, not directly, but through the deep system beneath them. When one activates, others sometimes respond, like a network waking up. Scientists call it sympathetic activity, and they're seeing signs of it now. Small earthquakes pop up along the chain. Nothing major, but unusual. A researcher points to a map. Red dots appear across the islands. These weren't here yesterday. Historical records show this happened before. 1848. Shishaldin erupted big. Within weeks, 3 other volcanoes activated. 1999, same pattern. Now it's happening again. The pattern emerges. Shishaldin isn't just a volcano, it's a node, a connection point. When it activates strongly, it signals something deeper. Something moving through the entire system. A geologist explains. Think of it like dominoes. One falls, others feel the vibration. But these aren't dominoes. These are mountains filled with molten rock. The data keeps coming in, gas emissions increasing, sulfur dioxide, carbon dioxide. These gases come from deep magma, fresh magma, not leftovers from previous eruptions, new material rising from below. The seismographs show another pattern, harmonic tremor, steady, rhythmic, continuous, like a drumbeat from inside the earth. This tremor means magma's moving, flowing through channels, rising toward the surface, and it's not stopping. In 1999, the harmonic tremor lasted 6 hours. Today, it's been going for 3 days. Scientists exchange worried looks. One speaks quietly. This is sustained activity, deep source feeding. Translation, the eruption isn't running out of fuel. It's being supplied from deep underground. A constant flow. That changes everything. Short eruptions are manageable. They burn out, cool down, go quiet. Sustained eruptions, those are different. They can last weeks, months, years, and they can escalate. The mountain's behavior doesn't match its history. It's stronger, it's longer, it's coming from deeper. Every measurement points to the same conclusion. This isn't a typical Shishaldin eruption. This is something bigger. The question scientists keep asking, how much bigger? Will it stay like this or will it grow? The data can't answer yet, but the mountain keeps showing its hand. More lava, more gas, more tremors. The pattern beneath reveals itself slowly, like watching a story unfold. A story written in seismic waves and thermal signatures. A story that says, pay attention. Because what's happening at Shishaldin connects to something much larger. The Pacific Ring of Fire isn't just a name. It's a living system. And right now, part of that system is waking up. At 3:42 in the morning, the seismic sensors peak. The numbers jump across screens, lava fountains breach 300 meters. The volcano enters sustained eruptive phase, its strongest in decades. And it shows no signs of stopping. Everything changes in an instant. At 3:42 in the morning, Shishaldin explodes upward. Lava fountains reach 300 meters high. That's taller than most skyscrapers. Molten rock shooting straight into the sky. Ash follows. A massive plume towers 10 kilometers high. Lightning flashes inside the ash cloud. Nature's fireworks. The mountain roars. Scientists watch in real time. Their screens light up with data. The eruptive phase just intensified. We're seeing peak thermal output. This is major. But it's not just scientists watching. Pilots see it too. A commercial flight crosses the Pacific. The cockpit radio crackles. Alaska Control, we're seeing significant ash plume, requesting course change. Air traffic controllers check their screens. Satellite data shows the ash spreading. Flight 720 approved. Reroute west, avoid the plume. Another pilot reports in. Visibility dropping, ash detected at 32,000 feet. That's cruising altitude, where planes fly. Volcanic ash and jet engines don't mix. The ash melts inside the engine, causes failure. Every year, 200,000 people fly over Alaska. All those flights now at risk within hours, multiple flights reroute. Some land early, others delay departure. The eruption isn't just spectacular, it's dangerous. Aviation authorities issue alerts. Red warnings flash across systems. Ashfall advisory, volcanic ash cloud, avoid area. Maps show the plume spreading, moving with the wind, covering thousands of square miles. Back at Shishaldin, the eruption intensifies. The lava fountains pulse. Regular bursts, like a heartbeat made of fire. Gas emissions spike. Massive clouds of sulfur dioxide rise. The smell carries for miles. A small town nearby feels the impact. Cold Bay, population under 100. Residents step outside. The sky glows orange. Thunder rumbles continuously, but it's not thunder, it's the volcano. One resident describes it. It sounds like thunder that never stops, just keeps rolling. Ash begins to fall, light at first, like gray snow. But it's not snow, it's pulverized rock, sharp, abrasive, dangerous to breathe. Families watch from their porches, kids point at the horizon. The glow spreads across the night sky, beautiful and terrifying. Wildlife reacts too. Birds fly inland, fish move to deeper water. Animals sense danger before humans do. Back in the monitoring stations, scientists track something new. Small earthquakes along the Aleutian chain. Not at Shishaldin, at other volcanoes, Mount Veniaminov. 100 miles away, small tremors, Mount Pavlov. Further down the chain, unusual activity. A researcher pulls up the map, red dots appear one by one. We're seeing sympathetic responses, another scientist nods. The chain's reacting. This is the domino effect. One volcano activates, others respond. Not full eruptions yet, but movement, stirring, waking. The Pacific Ring of Fire operates as a network. Pressure in one place affects pressure elsewhere, like squeezing a balloon. Push one side, the other side bulges. Shishaldin's eruption sends ripples through the system. Literally, seismic waves travel through the crust. Other volcanoes feel them and respond. The concern grows. If Shishaldin continues at this intensity, what else might activate? History offers clues. 1848, multiple eruptions followed Shishaldin's big event. 1999, same pattern. The Aleutian chain doesn't erupt randomly. It erupts in clusters, and clusters start with events like this. A senior volcanologist issues a statement. We're monitoring the entire chain. This isn't just about Shishaldin anymore. The eruption reaches its peak. A massive burst of lava. A sonic boom echoes. The ash plume punches into the stratosphere. That's higher than weather, higher than clouds. At that altitude, ash can circle the globe, affect weather patterns, block sunlight. One eruption, global effects. The mountain vents its fury, months of pressure released in minutes. But here's the concerning part. The pressure's rebuilding, fast. The eruption isn't emptying the chamber, it's being refilled from below. A continuous cycle: erupt, refill, erupt again. This is sustained volcanic activity, and it's not stopping. A scientist speaks into the radio. This isn't surface activity anymore. It's feeding from depth. Translation: the eruption taps into deep magma sources, sources that don't run dry quickly, sources that can keep feeding the volcano for weeks or longer. The breaking point isn't the eruption itself, it's the realization of what's happening. Shishaldin isn't just releasing pressure, it's accessing something deeper, something connected to the whole Aleutian system. And that system is vast, powerful, unpredictable. The night sky glows red for 100 miles. Ash falls across the island, planes stay grounded, and scientists worldwide watch Alaska, waiting to see what happens next, because when a supercone awakens, the story's just beginning. When the fire settles, the data speaks, and what it says is alarming. Scientists analyze the eruption, measure its power, calculate its effects. The numbers are bigger than expected. Energy release 4 times higher than the 2019 eruption. Ash volume massive, enough to fill a stadium. Gas emissions breaking records. This isn't just another eruption, it's a significant geological event. Maps show the ash cloud spreading, moving east over the Pacific, flight paths marked in red. All avoid the cloud. An FAA spokesperson explains, "We monitor volcanic ash in real time. Safety comes first. Every hour Shishaldin burns, flight corridors lose money, millions of dollars in delays, reroutes, cancellations. Nature writes its own flight plan, and humans have to follow. But the effects go beyond aviation. The ash carries sulfur dioxide, tiny particles, aerosols. These particles rise high into the stratosphere. At that height, they spread globally, and they affect sunlight," a climate scientist explains. Volcanic aerosols reflect sunlight back to space. This causes short-term cooling. How much cooling depends on the eruption size. Pinatubo in 1991 cooled Earth by half a degree. For 2 years, Shishaldin is smaller than Pinatubo, but it's still releasing significant aerosols, enough to affect regional weather, possibly more. Computer models show the spread, particles moving with jet streams, circling the northern hemisphere. One eruption creates global echoes. That's the power we're witnessing. Historical comparisons help understand scale. Mount St. Helens, 1980, explosive eruption changed landscapes. Pinatubo, 1991, affected global climate. Shishaldin isn't that large yet, but the mechanism is identical. One point on Earth releases energy. The whole planet feels it. That's both humbling and terrifying. Experts discuss ash particle behavior. These particles are sharp, glass-like, dangerous. They damage engines, scratch surfaces, harm lungs. Communities downwind face health risks. Cold Bay issues warnings. Stay indoors, wear masks outside. The ash keeps falling, light but constant, like toxic snow. Cleanup will take weeks, maybe months. But physical effects aren't the only concern. Economic impacts spread wide. Tourism drops. Nobody visits during volcanic events. Fishing industry affected. Boats stay docked. Ash contaminates water. Supply chains disrupted. Flights carry cargo too. Delays cost money. One event. Multiple cascading effects. Scientists track it all, creating models, running scenarios, predicting outcomes. One scenario stands out. If Shishaldin continues for weeks, aerosol effects compound. Northern Pacific weather changes. Jet streams shift. Winter patterns alter. Some regions get colder, others warmer. Precipitation changes. One volcano influences systems thousands of miles away. That's the interconnected nature of Earth. Everything links together. A researcher reflects, "We build systems to predict, to measure, to warn. But prediction isn't control. And sometimes warning comes too late." The eruption continues as they speak. Lava flows down the mountain. Ash plumes rise daily. The volcano doesn't care about human concerns. It follows its own rhythm, its own timeline. Satellite images compare before and after. The summit changed, new crater formed, glacier melted, the mountain reshaped itself. In days, geological changes that usually take centuries, compressed into a week. That's the power of volcanic forces. Another concern emerges, the other volcanoes along the chain. Small earthquakes continue, activity persists. Nothing major yet, but the pattern worries experts. If one activates fully, pressure shifts again, could trigger another, then another. Cascading activation across the Aleutians. Rare, but possible. History shows it happened before. Could happen again. Scientists issue careful statements. We're monitoring closely. No immediate danger to populations, but the situation remains dynamic. Dynamic, a careful word, means things could change fast. The public watches. News channels cover it. Social media shares footage. Shishaldin becomes famous overnight. Most people never heard of it before. Now millions watch its every move. The volcano doesn't notice. It continues its ancient process, releasing pressure, venting heat, reshaping land. What humans consider disaster, nature considers normal. Just another day in Earth's long history. But for us living through it, normal feels different. Dawn breaks over the volcano, smoke still rises, the glow persists. But daylight brings perspective. The mountain stands, still solid, still powerful, changed but enduring. Around it, life adapts. Birds return cautiously. Plants will regrow eventually. Nature recovers, always has, always will. But the data continues streaming in. Scientists don't stop watching because eruptions like this teach lessons about Earth, about prediction, about respect. Respect for forces beyond our control. The fallout equation isn't just about ash and aerosols. It's about understanding our place. We live on a dynamic planet, a planet that moves, changes, creates, destroys, and we're just visitors watching the show. Sometimes from too close. From space, Shishaldin looks calm again. The lava glow fades, the data quiets, but deep beneath that cone, heat remains. Pressure rebuilds, the pulse continues. This isn't an ending, it's a pause. Shishaldin's symmetry is deceptive. That perfect shape hides chaos, geometry hiding power, a reminder that nature's beauty often conceals danger. The most elegant formations hold the most explosive forces. Scientists keep monitoring every tremor, every gas reading, every thermal signature. They know the truth. Volcanoes don't stop being volcanoes. They just sleep between eruptions. And Shishaldin's sleep might be light. An expert gives final thoughts. We think in years. Earth thinks in ages. This eruption isn't an event. It's a message. A message about what? About forces beyond human timescales. About power that existed before cities, before civilization, before humans walked Earth, and will exist long after. The Aleutian chain stretches across the Pacific. 40 volcanoes, each one a window into Earth's depths. Some sleep, some smoke, some erupt. Together they form one system, connected through deep channels of heat and pressure. When one wakes, others feel it. The chain is alive, and right now it's stirring. Look at the footage one more time. Fire against snow, orange against white. The contrast is stunning. Beauty and destruction, creation and chaos, all happening at once. That's nature's truth. It doesn't choose sides. It simply exists, powerful, indifferent, eternal. We measure it, study it, try to predict it. Sometimes we succeed, sometimes we just watch in awe. Shishaldin taught us lessons about volcanic systems, about global connections, about respect. Respect for forces we can't control, can only observe, prepare for, adapt to. The monitoring continues. USGS keeps alert level at watch, not warning, not quiet. Watch means stay aware. Things could change. The volcano will erupt again someday, maybe next month, maybe next decade. Nobody knows exactly when, but it will, because that's what volcanoes do. They're not broken mountains. They're active connections to Earth's interior. And as long as our planet has a hot core, volcanoes will exist, will erupt, will remind us who's really in charge. Dawn light spreads across Alaska. The ocean reflects gold and pink. Seabirds call, wind blows, life continues. The mountain stands silent now, smoke drifting gently, waiting. Because beneath that silence, the heartbeat continues, deep underground, steady, patient, the pulse of Earth itself. This story isn't about one eruption, it's about understanding our world. A world more powerful than any human creation. A world that existed billions of years before us and will exist billions of years after. We're just witnesses, watching the show, sometimes spectacular, sometimes terrifying, always humbling. The Aleutian chain is alive, and so long as fire burns beneath the Pacific, the story continues. Shishaldin's story, Earth's story, our story, all connected, all one. The cone stands against the sky, perfect, beautiful, powerful. A super cone awakened, and the world watched.